Yo, 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 yo. Is this thing on? Does this work? Hello? Hello? Let me adjust this. Alright, cool. Can y'all hear me alright? Cool. Looks like it's working. Alright. So, where did we leave off? I haven't actually touched this in a hot minute, since last stream, so take a second to catch back up where I was, and then probably dive into some more coding. I think what I was doing last was I was setting up the key bindings. I got the key codes to work. Let me actually make sure this thing's plugged in. I got the key codes to work so that I can send keystrokes like Windows D, other stuff, which is nice because now I can go through and set up a bunch of key bindings within the config file. Sorry, I'm getting some stuff open. Need to attach some stuff to this virtual machine. Alright. Add our USB device, mountain display pad. Okay, cool. Alright, so... Alright, cool. So we've got that attached. Yeah, so now, with my code, last thing I was doing, I was messing around with the button presses. So now I can do things like emulate Windows D as a keybind. So you can see I'm running meta D. It actually goes through and sends that key press to the system. So that's cool. And all of that's being done through this library that I've written for the display pad. But the JSON config file is what I've been working on recently. This one right here, key mappings. So I've got this file that I put together, this JSON file that contains all of the button mappings. So I can go in here and change the value to something else. And then I also had a second action set up for execute so that we can run commands on the host operating system. This one I haven't actually fleshed out the functionality of yet, so we might do that today. We might also work on some of the image setting because I haven't messed with that in a minute. I think that would be entertaining to check out. So let's see. Where was I at? I think the last thing I was editing was we pull our input, and then we handle the key codes. So handle input key code. Alright, that gets the mapping. Alright, yeah, so this gets the mapping with the key code from the key mappings dictionary, and then we run our action.get. So we'll run the action and then the value. So in our case, we're running action keybind. That one's going through, it's taking a list of key codes, splits it on the plus. Then it goes and it gets the E code or the meta key or whatever it is. And then sticks that into the list, and then it goes and executes those. So this goes through and it iterates through the key code list of keys that we need to push. Then it goes and it writes the keyboard event for the key down. And then it goes through and it does the same thing for the same keys and writes the keyboard event for key up. That way it'll do a keystroke. Because say you're doing like Windows D, you want the Windows key and the D key pressed simultaneously. So that's what this achieves. And then it actually does the actual write command, or I guess synchronize command, where it synchronizes these keyboard events to the system. So that's where we're at. That's what we were doing last. So I guess let's get started on. Let's fill this one out. Let's fill out the action execute so that we can do this kind of thing. click our third button, we can execute bash echo hello or something. Let's actually do let's launch Firefox or something. All right, Firefox lives under user bin. Oops. There we go, user bin. All right. And then so we've got to do this with Python subprocess. So let's see, Python subprocess. So OS spawn is the OG, but we want subprocess run. Yeah, so you just pass it a list of arguments. So we'll need to grab our command line, split it up on spaces into an array, and then pass that to the subprocess run. That shouldn't be too difficult. Okay, so v is going to be our command. So command equals v dot split on spaces. And then we need a subprocess dot run command. So that should be pretty easy. And then our key mapping just launches Firefox. Okay. So if we save this and then we come over here to run it again, we push the third key, it should open Firefox. Hey, there we go. See, that was easy. Cool. So running execute user bin Firefox key 2 pressed. Okay, cool. So we've got that. That was actually way easier than I thought it was going to be. Okay, that's cool. Let's see. All right, so I guess let's mess with since that was a lot easier to do than I thought it would be, let's mess with the writing images to the device. So I have this monster of a function called ggsetPanelImage. The way I had this set up was where you can just pass it the path to an image file, and it'll go through and spit that onto the device, or send that over to the device through USB. The way I kind of imagine writing the code to handle this is that we'll have like a virtual display that's the same size as the image that we need to render to the device, and then we can take icons or take other images and stack those onto the virtual canvas and then export that whole canvas data to the device itself. But I'm not too familiar with Python image libraries. I think I was using Python Pillow. So maybe we can use that. I want give me the docs. All right, Python Pillow. So let's see what we've got. Image chops, channel operations, module, image draw, image file. 2D graphics for image objects. Use this module to create new images, annotate or retouch existing images, and generate graphics on the fly for web use. So I think that's what we probably want. So my thought is let's kind of brainstorm this a little bit, because it's probably a good idea to plan out this little bit of code. So my thought is virtual canvas. Let's see. Draw vcanvas to device. So virtual canvas is going to be comprised of, let's see, base image, icon images. So we'll need a function for the icon images, I'm guessing, to stick those onto the base image. base image, add icon, icon images, let's see, format, icon image, because we'll probably need to take the icon images, make sure that they're the right size, and resize them if necessary, transform them if necessary, and then stick them on the virtual canvas. To virtual canvas. Yeah, and then draw vcanvas to device. So let's start with the base image. Let's get an image generated by the Python pillow library as our base image. We could do like all red or something like that just for testing, and then once we've got that in place, then we can start adding icons to the virtual canvas. Yeah, I think that'll work. That should be good. All right. So coordinates, graphics, using concept, coordinates dismiss, pillow, zeros upper left, any pixels drawn outside the image bounds will be discarded. Okay. So image open, hopper.jpg is image, image draw image. So it looks like you can just draw right over all that crap. And then to save it, you do standard out. It says standard out to PNG. That's interesting. Okay, that just prints it to standard out. So I'm guessing we can stick like a file path here or something. Draw multi-line text. Creates an object that can be used to draw in the given image. Image will be modified in place. Okay. How do I make a new image? Because if I wanted to create like a new image from absolutely nothing, how do I do that? Draw bitmap. Image open and save. Provides parser. You can use decode images. Used to display images. All default viewers convert the image to be shown in PNG format. Okay. Okay, so I think we probably have to start with something like this. Oh, here we go. Image new. Look at that. Makes a new image, RGB format. I guess this sets all the values to white. I'm not sure what this is. I guess that's resolution. Okay, so we make a new image with the resolution of the screen size. Okay, that shouldn't be too difficult. Let's go and I wonder if we should open these up, put them into a new file. Let's do that. Let's put them into a new file just for shits and giggles. If anything, we can move it all out into that other one later. So let's go ahead and new file, import, and save this as I don't know. Just do image lib. Okay, so let's start off with defining a function. We want create vcanvas. And then I think we want c equals image dot new. Is that what it was? Oh, capital image dot new. Yeah, and then RGB, the resolution, res equals, what is our default res for this thing? (800 by 240). Okay. So it's 800 wide, 240 tall. So take this. This will be our res, and then on our default color, I just set that to 255. 255, 255, 255. Just like that. Alright, so you just use image draw, you make a draw object and then draw dot line. I guess that's starting position. I don't know, we could look into those. Optional mode used for color values. Image draw. Let's see. Arc, circle, ellipse, line. Yeah, XY between the coordinates and XY list. Oh, okay, so XY is a list of coordinates. Okay, sequence of either two tuples or numeric values. Okay, that's not too bad. Draw a pie slice, draw a point, draw a polygon. Rounded rectangle. That's nice. We'll need this for our actual buttons. Let's just grab that real quick. Go into def, add, icon, path. And I want to open this up. How do I do that? Image.open. Okay. Give the image path and then, okay, cool. Then we give it the path to the image. So we're going to need that rounded rectangle at some point. I did mention that the pixels that are drawn outside of the canvas are erased or just thrown away, so maybe we can use that to our advantage if we do a rounded rectangle. But the images are still going to be... Oh. Hmm. Let's see. Yeah, that's interesting. I'm not too sure the best approach for that. Let's just stick with the virtual canvas first, and then we can worry about sticking icons on it later. So make our new image of the resolution size. We can send that to the device right now the way it is, but we want to stick an image onto it or stick an icon onto it. I want to make an object. Let's do a virtual canvas. Let's see. Yeah, and then we can define it up here and store it in here. That should be fine. Okay. All right, got a virtual canvas. vcanvas create. So on init, we do a self.create vcanvas. And then self vcanvas. Or actually, we'll just do canvas equals C. And then over here, we can do import image. Let's see, image lib. And then let's do self. What do we call it? Vert canvas. Yeah, I think that'll do it. And then I'll create the vcanvas. Create it with the resolution that we want. It'll be all white. And then let's go ahead and let's make a function for getting the actual raw image off of it. Def output. Or we'll do I don't know, get content. Don't forget to add our self. And then we'll just do a return self.canvas. What was it that you got to do? Draw. What do I want? Examples. Just give me the examples. Show. Draw multi-line text. So I wonder, because my function that I already have for writing images to the device takes a file path. This takes an image path. So I could write it to the disk first, and we can just look at it that way. Because then we'll just pull it from the disk when we go to write it to the panel. So let's see. And we'll do with open panel image .png as rw as f, and then f dot write self dot c, or self dot canvas, not self dot c dot what was it, show? No, there we go, it's image dot save. Do you just where is the save function? Image file module, image draw module. Here it is, image module. Where is our save? Alright, saves the image under the given file name if no format is specified. Format used to determine from the file name extension if possible. Okay, so you don't even have to do the with open. Neat. That's cool. So we can just do self.canvas.save and then give it that. And then this will be PNG. Alright, so let's try. Let's do Python 3 import image lib, and then let's do c equals image lib dot canvas. No wait, am I dumb? Dot vert canvas. Vert canvas. And then we need to call save canvas, and that'll, yeah. So c dot save canvas, yeah. So now, oops, not that. Desktop, RFF, display pad. So now we should see this panel image right here. Cool. Okay, so this is our sample image, or sample PNG that we need to then write to the device. Okay. So now, got that being made. Let's do the add icon. Let's get an icon really quick. I don't know. Cool. This one looks good. Oh. I hate fucking Google image search, man. Good enough. Alright, sample icon 1. Cool. So what I want to do with this is take this, resize it down to the resolution that it needs to be for the icon, and then stick it on the virtual canvas. I think that's a good first step. Okay. So add icon path, image icon. So opens up the image. Let's see how we resize this stuff. Also we need to do a little bit of math to figure out what our like offset spacing and everything is going to be for these icons. So let's see. Do, 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 do. All right, is there a resize? Here we go. Returns a resized copy of this image, the requested size in pixels as a tuple or array. Width and height, resample, box, and optional 4-tuple floats, providing the source image region to be scaled. Oh, so you can scale a region. Hmm. Could also... Okay, so I guess what we want to do is we want to take our image, our icon, right? We want to shrink it down to the right size. Then we want to take all the pixel data from that shrunken image, translate that over onto our panel in the right position that it needs to be, based off of 1 through 12 on the button. Okay, so we can resize it, and then we got to get all the pixel data from it, and then write that pixel data to our canvas. Okay. Let's see, so we'll need a position. We need a position for the icon. Actually, let's just do, yeah, because we could simplify where it's just, you give me a number of the key. Let's just do key num. Because if we've got 12 keys, if our number is higher than 6, we know that we need to draw it on the second row, down one row. If it's less than or equal to 6, then we can draw it on the upper row. So resizing it. So let's resize our image. Icon image dot resize. Yeah, returns an image object, image dot resize. So size tuple. And how big do we want to make them? So let's have Krita. No. GIMP? No. Paint? Anything for paint? Nothing for paint? Okay, whatever. Let's go ahead and go back into Windows because Windows has paint. The power of virtual machines. Alright, so for example, we want, this is our, let's say this is our 840, or 800 by 240 pixel image, and we want to, we've got our individual buttons. This is going to be awful, by the way. 3, 4, 5, and 6. Okay, so this is going to be awful. I am not an artist. Well, I mean, I do pixel art, but this is lazy art. So we've got 6 buttons, and then we have another row of 6, so we need to so if our width is 800, we divide that by 6. That gives us at most 133 pixels for each icon if we're having them butt to nut. And then we want some padding in there of like, I don't know, it's like, what, 5 pixels? So 5 times 6. And then we'll subtract that from, no, because we'll have to subtract 5, or we'll have 5 pixels in, and then we'll have an icon, and then we'll have another 5 pixels, and we'll have another icon, and we'll have another 5 pixels. So it is the number of icons times 5 plus 2? So it's 6, 1, 2. Okay, so we have 1, 2, 3, 4, 5 on the inside, 6, 7, 7 spaces. Yeah, so 6 times 1 plus 1. Okay, so it's that number plus 1. Okay, so for our padding, we do like say 6 times 5 plus 1, and that'll give us the number of pixels that we need to pad. Yeah, working with pixel math it always breaks my brain. Okay, so let's go ahead and let's resize our image. Let's just do 64. Let's do 64 by 64 for now. 64, comma 64. We'll look at how it shows up on the actual image file. And then we'll fudge this and, move it back and forth and change the values until we get it to where it looks good on the device. So that's something that we can come up with later. But if I went and like reversed the actual stuff in ghidra a little bit more, like the this set panel image function. Am I in the right one? Oh, exports. Let's see, set panel image. This one. But if I reverse this a little bit more, I can find out the actual offset that they have between each image. But that's, I don't know, that's a lot of work for not much gain. It'd probably be a lot easier to just fudge the numbers until you get the right offset for the images. That's okay. So so our image resize takes a size, and then optional resampling filter. What is the default? Default is by cubic. Okay. Source palette. Oh, that's remap palette. I'm looking at the wrong thing. So that's it. You just give it the width and the height. Okay. So let's do that. Let's give it the width and the height. So we resize it to 64. And then let's stick it on the virtual canvas. So we'll just say key number is 1. Let's see, icon position equals actually let's just do icon x equals key num times so say if our key num is 0, we're not gonna change the offset, but we're gonna add +5 for the let's just put it at 0. I want to see if it actually goes on to the thing first. We'll do 0, 0, and then let's see self.canvas. Image draw. So let's see, draw. Can I draw an image over an image? Draws a bitmap mask at the given position using the current fill color for the non-zero portions. Oh, to paste pixel data into an image, use the paste method on the image itself. Paste another image into this image. The box argument. It's either a 2-tuple giving the upper left corner, 4-tuple defining the left upper right lower pixel coordinates, or none. Okay. So should be able to paste the image. Box is optional for tuple, giving the region. If a two tuple is used instead, it's treated as the upper left corner. Okay. So self canvas dot paste, and then we want our icon image, and then let's see, icon X comma icon Y. So then if we come into here, oops. So I need to add icon. Let's see. C.add icon, and then icon path is going to be dot sample icon one dot png, right? Is that what it is? Sample underscore icon one dot png. Okay. Oh my god, I cannot alt tab. Saved my life. Sample underscore icon one dot png, and then let's just do 0 as our key number. Message file or directory. Is it not a PNG? Oh, it's a JPEG. I'm dumb. Sample underscore icon one dot JPEG. All right, and then C dot save canvas. All right, so then if we go into here, we look at this. Nice. So it got got resized from this to like just that, and then placed right there. I don't think it resized it. Let's see. Oh, it's done in place, right? Icon image equals icon dot resize. Maybe we need to do that. C equals vert canvas. And then C dot add icon. All right, so now we can do this without having to like do a bunch of crap, or without having to like rerun this over and over in the interpreter. Image lib.py. Oh. So then if we check this out, there we go. See, look at that. So we've got a 64 by 64 version of that that's stored at the top left of the device, or of the image. Cool. So then if we write that to the device, if we write this whole thing to the device, it should actually show up. So that's neat. Let's see. All right. Well, I think we're coming up on an hour of streaming at the moment, so I think it's a good opportunity to take a break. We made a little bit of progress, getting some functions for the image library going, so that we can write to our virtual canvas and then write that to the device. So we got some good progress. I think I'm gonna take a 5 to 10 minute break, and we will be back and keep going at it. Did anybody have any questions or comments before we take a break? I need to top off my bean water. All right, well, let's go ahead and take a quick 5 to 10 minute break, and we'll be back. We'll see you then, and we'll keep going at this, and hopefully get some images right into the device today. Okie dokie. I'll put you guys on the waiting room with some cool jams. Okie dokie, we back. What up? Can you guys hear me? Is this thing working? Hello, hello. Alright. Looks like my audio is working again. Cool. So I got some fresh bean juice. The fresh bean juice. Courtesy of the Sanford Underground Research Laboratory. You guys should go check that place out if you've never been there. It's in South Dakota. It's a giant underground research lab. I believe it is the neutron detection array. Neutron or neutrino? Neutrino detection array. Place is pretty cool. It's like an old mine that they hollowed out and they used like all the old passageways and everything. And the fact that it goes super deep into the earth, they used that and they went down there and put up like a huge neutrino detector array. It detects neutrinos. It's pretty neat. So anyway, we're working on our image library. So we've got our icons being spat out onto the images like so. Um, so we need to set up some padding so that they get placed into the right position. I think we need at least 5 pixels on the whole top row, and then 5 pixels between each icon. So let's go and let's mess with this right here where it's drawing based off the position. So let's do a little for loop. Let's do for I in range 12. And then we'll swap this for I. Save that. And then if we rerun it, we should have this full of stuff. Or not. Oh, it's probably, that's right, I'm not actually modifying the position, so it's just pasting it right over itself. So icon Y is going to be 5, because we want that, and then icon X is going to be 5 plus, let's see, 64 times keynum. So I would do 64 for each keynum. I think that'll do it. It's probably not right, but whatever. Okay, 1, 2, 3, 4, 5. So we've got 12 of them. They're not padded in the middle, it seems, and they're not padded, or no, they are padded up top. Oop, can I make this bigger? Yeah, so we've got the padding over here, and we've got it up here, but we don't have it in between each one. So we need to add another padding onto that. So this 5 is going to be plus, we want keynum times 5. I think that'll work. We'll see. Because we need to multiply our padding by the number of icons that we have. So there we go. So that gives us the 5 pixels of padding in between, and the 5 pixels up at the top. Okay, so now what we need to do is we need to iterate, or we need to check and see if our keynum is greater than 6, and if it's greater than 6, then we change the offset for the second row of keys. So let's see if keynum is greater than 6, then what we do is, actually, what we can do, move this down here. So if our keynum is 6, then what we want to do is we want to take icon y, and we want 2 plus equals, so 240 divided by 2 is going to be 120. So, just do res divided by 2 plus, let's make sure that this is an integer, by 2 plus, I don't know, we'll do 5, plus 5 as an offset. And then rerun this. Oh, res is not defined, okay. Self res equals res. So then we can come down here and, where is that? I just missed it. I just lost it. There it is. Self.res. Cool. And come back over here, rerun that. And then if we check out our image again, ew. Okay. So we need to reset our X offset, because that's still getting, that did position it like halfway down though. So then we can do icon X minus equals, I should do icon X. Can we do that? No, that's dumb. Can we subtract the width? Self.res, oops, 0. That's probably not going to do it. That'll make it come all the way off the screen. This is the part where I get real stupid. Like keeping track of math in my head. It's not my forte. So what's the best way to do this? I want to have it so that once it's over 6, if our key number is over 6, then we have a different calculation for this. Could I just do this? No. Key num divided by 2. You can't divide 0. Source box cannot be defined as inch. Oh. Yep, gotta convert that to a float. Oops. I'm gonna convert it to an int, not a float. It's already a float. Okay. So maybe that'll that'll limit our rows to 2. But then it still puts it right there, and I'm not getting the full 4. That's a mess. That's ugly. I don't like that. We can do icon X minus equals 64 times 6. That puts them right there. 1, 2, 3, 4, 5, 6, 7, 8. Wait, that's not right. So that's 7. I need to. Yeah, that's 7, 8, 9, 10, 11, 12. So it is doing 12. Oh, less than or equal to 6? Or greater than or equal to 6? No, just greater than 6. So that must be... Is it getting printed out as, or sent out as 1 instead of 1 instead of a 0? It is, it's a 1, so come in here, we've got 1 times 64 plus 10 for the offset. Yeah, so that's 5, that's 5. Oh, this hurts my brain. Hmm. No, weird. Okay. Hmm. So I guess really what I need to do is I need to... Interesting. Huh. Trying to trying to think of what the best way to actually get this get these things positioned properly. I could just hard code some positions on the image. That might honestly be the easiest way to do it, is hard code some positions for the numbers. Um hmm. I could clamp that value and have it so that it stops, but I don't know if that's super helpful. Hmm. So if our key number is greater than 6, then that means we're in the second row. We need to increase our y value, which we're doing, and then we need to start fresh on the x value instead of utilizing this same exact one. Actually, so can we... Okay, so let's do key posts equals keynum integer keynum divided by 2. So then we can use the key position. And then that way, if our key number is higher than that, then we can do this. And then that way, I don't know. Let's see what that does. I'm a visual person. I gotta see changes. So 1, 2, 3, 4, 1, 2, 3. It's only giving me 7. That's confusing. All right, let's do some debug print statements. Print key num and key posts. And then let's print icon X and icon Y. So 0, 0, 1, 0. 2, 3, 4, 5. All right, 1, 2, 3, 4, 5. So that's 3, 3. 281, 281, 5, 5. Okay. It still doesn't give us what we want, but I don't know, that doesn't make any sense because the way that Python's doing the rounding is it's gonna round the float down, and so we're not getting the exact, I don't know. Okay, so let's just do let's designate. Let's designate if it's top or bottom instead of doing that. And then we can just iterate through 6 over here. Top. Wait, let's see. Dir equals no. D equals so if our key number is greater than 6, then D equals so that'll set our row. Let's just name that to row instead of direction. So if our key number is greater than 6, then our row equals 1. Then we want to set our position based off of the row. Let's see, plus row times I don't know, 120. Actually, we'll do this in a check. So key number is greater than 6, then our row is equal to 1. Then our icon Y. Oh, it's already doing that? Okay. Move this back up. And then what do we want to do if our... So we want to multiply that by the row. That handles our... Okay. This is where it gets weird. So we're passing through values 1 through 12. Then when we get over 6, we need to loop back through 1 through 6 again, as opposed to going through 12. So... Ah, that sucks. Why is this breaking my brain so hard? So, I guess let's go back in MS Paint. Nope. All right, so this is 1, 2, 3, 4, 5, 6, and then we've got 7, 8, 9, 10, 11, 12. Oh, I'm dumb. Can I just subtract 6? Oh, I'm so fucking stupid. Just subtract 6 from it. Oh my god. If key number is greater than 6, then keynum equals, oops, no, we still want row. Actually, do we even need that? Keynum equals, right, minus equals 6. That should do it. Wow. But we're still getting 7 up here, 5 down here, instead of 6 and 6. So, is that greater than or equal to 6? No, it's gonna give me 4 at the bottom, right? I get 7 at the bottom. Because it's not printing, we're not printing out the, let's see. I don't need that. And keynum. 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So greater than, we don't want greater than or equal, we want greater than 6 minus 5. I think that's what we want. That might not be it, but 6, 7, 8, 9, 10, 11. Now we're 1 short? What the fuck? This didn't work. They gave me 7 up here. Why is this not making any sense to me? See, if I do 1 through 11 down here, and then run it again, that's only going to give me 11. Wait, 6, 7, 8, 9, 10. Wait. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What? Okay, so let's try this. Let's just try it. Let's try something. Let's try something. We are going to take this. We're just gonna put it in position 7. Should be first one in the second row. First one, second row? No. No? Yeah, I guess that's first one, second row. But why is it so far over here? I never asked myself that. So our X offset is 5 plus that plus key-num. Oh, that's right, because we're starting at 1 instead of 0. Oops. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now we're getting 1 extra key. Yeah, I knew there was one that wasn't making it there. So let's do that. Rerun this. Go back over here. Yeah, so it's like, that's 7. Wait, does this need to be greater than or equal to 7? Let's do that. That might give us what we need. Nope, still got 7 up there. Oh, that's confusing. Alright, so when it gets over here, we're setting our key-num to -6, but we're not iterating it back to, no wait, we are. Oh, we need to minus by 7. I think that's what we need to do. I don't think that's right because we're doing 7 instead of 6, but that puts it in the right spot. But we're still pulling 7 off instead of 6. We want to put 6 up at the top, 6 down at the bottom. Da, 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 da. There we go. 6 up top, 6 up bottom. 6 up bottom. Okay. So now we are not, let's see, we're not getting the offset properly. No, we are. Okay, so we're getting the offset properly for that and offset properly for this. So now we just need to figure out the right size we want to set these images in order to get them in the right spot. So looking at the device, we could probably make like a test pattern, like in, oh my god, I've got the fucking Windows one open the whole time. You guys can't see shit. Okay. This is my my Linux VM, for those of you who missed what I was just trying to show off but didn't. So I set this to check and see if our key number is greater than or equal to 6, and then if it is, we're subtracting 6. That way it accounts for the second row when it comes down here and it does the X offset. So when we look at that, we can see that we've got our 800 by 240 pixel image, and our top row is getting 6 icons, and the bottom row is getting 6 icons. So if I come back over here and I comment this out, and I come down here and say I just want to set an icon to uh, row 2, icon number 1, which would be key number 7. Go and run this again, double check and make sure this actually goes into that. No, it doesn't. Okay, so this one's being, so it should be right here, not right here. I had it at 7 before. That wasn't right though. No, that put it in the right spot. Because you'd have 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12. Okay, so that's got it in the right spot. Okay, so I think that's right. And let's come back over here. I want to test this again. Comment or uncomment that. Come over here, render it again. Yeah, and see we're getting 7 over here. That's what's been confusing me about it. It's probably just the way that Python is doing lists and iterating at starting at 0. Is that what I need? Because technically counting 0 is an item. Hey, Oboki7. No, I'm reverse engineering and writing some Python for a knockoff Stream Deck. So I've got this piece of hardware right here. It's like a little Stream Deck thing. You know, it's got a screen with some buttons. And it doesn't work in Linux, so I'm reverse engineering it to get it to work in Linux. So I'm writing some drivers for it right now. Kind of a pointless task, but it's fun and I'm learning, so that's all that matters. Get this thing plugged back in. The freaking Type-C port on this thing is awful. Okay. So right now I'm working on the Python code to actually write the images to the device. So I've got some, this is the library that I've put together, the Python code to actually talk to the device. Up here at the top, we've got like a bunch of headers for the various USB messages that need to be sent to do different things, like getting firmware information or enabling stuff. A lot of this is like unused, mostly because it was just me testing and reverse engineering it, trying to figure out what all the different messages are. But I've got some code down here to actually send an image to the device. So this one is what sets our panel image. And it goes through and it sets the whole 800 by 240 pixel image to the device. So right now what I'm working on is I'm working on some code to render a virtual canvas with the Python Pillow library, and then take icons, actual image icons like this sample icon right here, and then stick it on top of that virtual canvas where it needs to go. So in the future, when I've got this a little bit more fleshed out, when I want to actually put icons in various key positions on the display, all I have to do is say, hey, I want to add an icon from this path, and I want it to be in this key number position, so that my code over here can automatically render the image to the device with all of the key icons in the right position. So that's kind of where we're at right now, is trying to figure out the pixel offsets for the buttons, for the icons. So I'm trying to get them all rendered in the right positions, so that we can then take this final image and send that to the device. Hope that makes sense. If you have other questions or you want me to like kind of detail something else, just throw it in the chat and we can dig into it. So I've got those. Those are being placed. But the problem is that I'm not getting the right number of icons, so it's kind of annoying. So if I want to, because this puts 6 up here and then 5 down here. Let me run this again with 12, place 12 icons on there. And I'm getting 12 and 12. But if I go and say I want to position this to, if I want to put an icon on position 7, and I run it again, it goes and it puts it on position 8. So that's not where I want it. I want it on position 7. So I think what I need to do is I need to actually, no, I think that is right because my Python code is based off of indexing on 0, or at least this range starts at 0. I could start it at 1, but then my offsets would be wrong. I'd have to readjust those. So really it's about I could just keep in mind that the keys that I'm sending to the thing. Let's look at the code that I have for the actual key presses real quick. Because if the key codes that I'm sending are 0 through 11, then that works. Which they are, so 0 through 11. Then I don't have to worry about it. I don't have to worry about like subtracting 1 or something like that before I go and pass it to that part of the code. So I guess let's try sending it to the device. If you guys want to see that, let me put you in the idle room real quick, and let me adjust my camera to pick up the device, and then we can show off trying to write images to the device. So give me just a couple minutes, and I'll get that that camera set up. So one moment. Alright, so hopefully you guys can see this. I got my little stream deck thingy going. Might be a little too dark. Alright. Let's go ahead and get this attached to the virtual machine. And then we can start poking around with it. So let's remove this. Add hardware, USB device, mount display pad, and we'll see it turn on. It'll go through and do its crap. Alright, so, where do we want to actually run this at? So we're getting our sample icon. Let's just go ahead and do all of them, just for starters. Actually, we don't need any of this, because we're going to call this code from our mount display pad. So we do that. We've got our virtual canvas being defined right here, so then we can how do we want to do this? Let's just define it in our fuzz USB, I guess. Or because I don't want to update the panel image every single time like constantly. I only want to update it every single time there's like an actual update that needs to be sent. So let's just call set panel image. And then what we'll do in set panel image is we will get the let's see, if image path, let's see, else. So if we don't have an image path, then what we're going to do is we're going to get the image from our actual canvas. Image data equals self.canvas dot 2 bytes. No. XBM, RGB. Right, -1, right bottom. Okay. Technically, we really only need to do that right here. And then we can have the rest of this occur anyway. Like so. That way, if we don't pass an image path to this function, set panel image, it's going to go and get the image from the canvas, which is going to be a Python pillow image, and then we're going to convert that 2 bytes, and we're going to do all the normal stuff that we normally do with it. Okay, so then what we want to do is up here under our init, where we make our canvas, let's go ahead and for canvas self.canvas, actually, image lib, or no, okay, self.canvas dot, what do we want? Add icon, right? Add icon, sample icon position 7. Let's do that. Right there. Now, when we run our fuzz USB, it should go through and put an image on the display. Should. Or not. Okay. Am I still getting button presses? Yes, I'm still getting button presses, so that's doing stuff. But I'm not getting an image. It did write all of that. Oh, so do I need to... Where's my image writing function? So this adds an icon to it, and then when we add the icon, do we write it again? Hold on. Oh, I need to save canvas. That's what I need to do. I forgot to do that. Self.canvas. .save canvas. It should still be all white though. If anything, it should still print like a full white image to the device. Because right here, we're making the whole ass thing. But it's not doing a canvas save, is it? We don't need it to. We don't need it to save the canvas into a file because over here, we're just getting the image data from it. So set panel image. Image data 2 bytes. Oh, am I not? I'm not keeping it as bytes? Am I doing that wrong? Oop. So that's still working, but we're not getting any of that. So it's still not writing the image to the device. Okay. Is that the print one image data? I think so. Or no, wait, are we not? We're not even calling set image, set panel image, are we? So gg set panel image. Oops. Come on now. Yeah, see, I don't think we're calling this. Okay, yeah. That's why. So we need to set this up over here, uncomment that, and we're not going to give it a path because we just want it to do the canvas image. So that should do it. That's probably what was fucking me up. Okay, so Control C out of that. Fuzz the USB again, and either it's going to work or give me an error. Virtual canvas object has no attribute 2 bytes. Okay. I like that. I like errors. Image.open image path, image 2 bytes. Self canvas has no 2 bytes method. So we're making a new image, saving that. Let's check our method. So that's our parser, but we're not using that. Turns an image object. Copy this returns a converted copy of this image. For the P mode, this method translates pixels through the palette if it's emitted. Where's my 2 bytes? Image.2 bytes. Returns image as a bytes object. This method returns raw image data derived from Pillow's internal storage for compressed image data. E.g. PNG, JPEG, use save with a bytes IO class for in-memory data. Oh, do we need to save it? Might be what we need. Okay, so let's just make it so that we save our image. Yeah, so every time we add an icon, let's call self save canvas. Self dot save canvas. We'll call that. And that'll save it, and then we can just load it from panel image.png. So let's go ahead and then let's do if not image path, and we set our image path to the default panel image, and we open that. Okay, so that should all be the same. Let's try this again. Hey, look at that. So we got all white written to the device, so that's cool. You can see our little icon. Kind of hard to tell, but it's on there. So that's cool. We can go ahead and change that. I want to set this to all of them. Or is it fuzz USB? Let's set panel image. Doo -doo -doo. Okay, so now what we can do is we can set up a JSON config file for all of the icon images. So we can set this in our config file. So we will, let's do this. Let's go ahead and I don't want to hand edit JSON all day long. It's kind of annoying. I might make a function to update this data for me. Let's see. So we can come down here and make some functions for the config. I don't know. I'm trying to think what would be the best way to manage the images that I want stored on each key. I'm thinking I could keep it simple and have like a path to each image file stored in the JSON config, and then have like a front end to load the images. So like a little browser thing, file browser to find the images. That's to make it real end user easy. But for me, I could have it just basically just be a path to all of the icon images that I want to use, and then have it load those to the virtual canvas, print that out on startup. And then make a couple functions that will come in here and wrap or put a new file path. So if you wanted to update the image, you could load it in there. Because what we're going to need to do is make it so that our library resizes our icon images to the appropriate size, places them on the virtual canvas in the right position, and then saves that virtual canvas to a file, which it then loads onto the device. So, interesting. What is the best way to do that? Yeah. I think just setting up the icon path is probably like the best way to do it. So we can just add this to all of these like so. All right. So we've got icon paths now. So what we can do is come in here and we can load our icons. Let's make a function for loading icons. Load icons. We'll pass ourself. And then what we want to do is we want to run this with open key mappings. Actually, we could probably just do it under the same function. I think that's probably better. But that just returns the key mappings. Where am I calling that from? That seems pretty useless. That's a pretty dumb function. We're loading our key mappings up here, right? So this is our, what is it, load key mappings. Puts it in there in the dictionary. So then we can just iterate through the key mappings. So let's do self.keymappings equals, do it down here instead of assigning it up here, equals none. Oops. So let's do self-load key mappings. Okay, so that'll go through, that'll set our key mapping variable. And then what we want to do is iterate through our keys. So for key in self.keymappings, and I can't spell self, self.keymappings. And then we want to load our icon. So icon path equals key.get icon. See if icon path. And what we do is self.canvas, or no. Yeah, self.canvas add icon. And then we want to give it our path icon path. Right? So add icon path and then the key number. Oh, and then the key number. Okay, so key mappings. That'll be the key number. Let's see. And then this should be int key. I think that's right. That's probably going to spit it out wrong. Let's see, print key. I think I need to do enumerate. Let's just do enumerate. Key code and then mapping. Let's see, and enumerate. So we want to enumerate through that, and then we can have key code. Let's see, mapping, get icon, and then key code. All right, there we go. So that'll load all of our key icons from these icon paths. They're currently empty at the moment, so if they are empty, we don't do anything. If they are not empty, then we add an icon. So let's try that. Let's go ahead and go into our key mappings, and then for the first key, we will do dot sample icon 1.jpg. Right, that's what we got. Sample icon 1.jpg. Okay. And then we want to go back over here. So this is going to load key mappings. This is going to add the icon. So if we come to our fuzz USB, it'll do gg set panel image. And then let's make sure that this is all in the right order. So we load the key mappings. We don't want to do this until after our canvas is set up. So we take care of those. We don't need that stuff. And then this is going to go up here to below before our key mappings, because that's got to be initialized first. Okay, let's try this. String object has no attribute yet. Okay, so I mean string object has no attribute yet. Bruh. It's key and value. Let's see, pretty.pprint self.keymappings 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then it's got that value is A. Print key code mapping. What am I enumerating wrong? 0 and 0. Oh, that's because I'm not supposed to use enumerate. I'm supposed to use items, like a fucking idiot. Wow, look at that. It worked. Okay. And you guys might have a hard time seeing this, but we've got an icon on our first key. Hooray. Yeah, my camera's being dumb, but that's cool. So we've got an icon on our first key. We can press buttons so it actually does something. So we're getting there. So it looks like those icons are supposed to be maybe 256 by 256. I'm not too sure. It's kind of hard to tell. But we can try doing a let's see. We could do like a little grid image, like a test image that's got a grid on it based off of how big the pixels are, maybe. So that might be a little hard to do in Microsoft Paint. Sample pixel grid image. Yeah, that's an option. Alternatively, we could just fudge the numbers until we get the right size. So we can come into like here, this image library, and change these to like 256 by 256. And then we can rerun it and see what that does. And that should give us a larger, wow, that's much larger. That's like occupying the whole ass thing. So that's not super good. So it's definitely not 256 by 256. Is it 128 by 128? Let's try that. That still might be too big. So that one updated. Let's see what that gave us. That one looks a little bit better. Yeah, I think that's it. 128 by 128. It looks a little too big. Looks slightly too large. Ever so slightly too large. So, could adjust this a little bit. Oh, so maybe we don't need padding on the far left and the far right. So we probably don't need that padding. Because then when we run the image library again, let's see. Oh, that's not gonna work because I don't have that uncommented. So that one goes and it makes, those are 128s by 128s. Oh, I need to adjust that so that it offsets it by the size. So this is going to be icon image.x, right? Or width dot width. There we go. I think that'll do it. And then we come over here, run this again. And then we look at this. I'll close out of that. I don't need that. Don't need that. There we go. So we've got 6 and 6 with a 5 pixel gap. Let's send that to the device and see what that looks like. So we'll do this for eye and range. Go ahead and add that. And this is going to be self.canvas. Self.canvas, add icon. So let's put 12 icons onto the display pad. And we should see that pop up. There we go. So now I've got 12 icons on there. Let's see. It looks like they're cut off a little bit on the bottom. So I don't know if you can see that, but it looks like they're cut off a little bit on the bottom. So we've got to adjust that a little bit more, but we're getting there. It also looks like that, looks like the horizontal offset, like the spacing between them isn't accurate enough. So that's, I mean, we're getting there. Slowly but surely. All right, so Let's change our offset to 10 pixels. I think 10 pixels might be it. That might be the magic number. Let's do horizontal. Let's just do H offset. Offset equals 5 or 10. So this will be H offset. So that should do that. Let's run our image lib. Actually, we'll just do the whole fuzz USB again. And that should move them. See, now they look a little bit too far to the right. I don't know. I mean, I need a border around this image. So let me put like a 1 pixel by 1 pixel border. Actually, let's do this. Is there an image editor? I guess I could just install ghidra. Let's see, sudo apt get install ghidra. Alright, well, while this installs, anybody got any questions? Y'all having a good day, hopefully? Is this fun? Is this enjoyable to watch? Watch me like poke around at this hardware, get it to do stuff in Linux. All right, so that is installed. Let's, oh, we don't need to exit out of that. So, ghidra. So let's go ahead and make a 128 by 128 image with a pixel border, a 1 pixel border. So then we can start sampling this. 128 by 128. Resolution 300, great. View, show pixel grid. Okay, cool. Let's do, select this, selection, shrink selection by 1 pixel, Control Shift I, invert, and then we will backspace. So that should give us a 1 pixel border around that image. And then, just for fun, put a smiley face on it. Cool. So we'll save this as desktop, RFF, display pad, and we want PNG. No, I guess it doesn't matter. Just to keep it simple. This is the JPEG image sample icon 2.jpg. Okay, cool. So now we've got that. So let's go back into Sublime, and we want to come up here, sample icon 2, do that, and then we come over here and rerun our fuzz USB, and we'll stick that icon on our screen. So what we're seeing over here, and again, this might be hard for you guys to see, but I can see the 1 pixel border. It looks like it's Looks like the Y might need to be a little bit higher. So like we don't need the Y offset up at the top, but we may need it in the middle. And then our X offset seems to be a little too big. That seems to be a little too big. So we can adjust that. So our Y offset, let's just have that as 0. Actually, icon Y is 0. We'll do Y offset equals 0. Y is Y offset. So we set our Y offset to 0. And then let's set our H offset to like 7. I don't know. That seems odd, but I mean, it is odd. It's an odd number. That's how they work. Fuzz USB. Go through and set that again. Alright, how are we looking? Let's see. So I don't see our border up at the top. So that must be good. I don't see our border down at the bottom. Our border in the middle seems to be good. Let's I want to widen that. I want to widen the H offset until it's too wide, until I can see it between the things, and then drop it down. Just kind of fuzz it. So let's do 15. And then we rerun that. Alright, and then those guys pop into place. Oh, it looks like it's cumulative. Or not. Because it's like, on the device, that first one looks good. But then the more they get added on, the more they're like shifted over to the right. So I'm not sure what the deal is with that. Let's see. So if we have 800 divided by 128, oh wait, 800 divided by 128, 128 times 6 gives us 1.04. That gives us 0.04 of that remaining to be distributed into our buffer. 128 times 6, 768. So it gives us 32 divided by 6. Gives us 5.3 pixels in between each image. So technically it should be, I should do 6 for the H offset. And that should look about right. Alright, so it's popped into place. And yeah, that looks pretty good. We could probably increase the Y offset. I think maybe there does need to be a little bit of a Y offset. So we change the Y offset to like, I don't know, 3. or something. It's not a whole lot, but it's enough. So that puts it right there. Let's see. Let's do let's look at that. Oh, see, I put the Y offset up at the top, not in between. Okay, let's adjust that. So our Y offset, icon Y is 0. Icon Y equals Y offset. And then let's run that again. Yeah, okay, so that put the Y offset right there. Our H offset's a little weird though. So if I come down and change this to, let's change that to like 5. Just for testing. All right. So that gives us that. So it puts, that doesn't seem like 5 pixels, does it? Yeah, that doesn't seem like 5 pixels to me. I mean, it could be. No, because our H offset is 6. Our horizontal offset is 6, and that's 6 pixels. This is definitely not 5. What the hell's going on there? So that's 5 plus the height of the resolution divided by 2. Oh, this needs to be Y offset. No, we don't need to do that. I don't know if that'll actually fix the offset issue, but see, now the Y offset's back at 0, it looks like. Oh, I need to multiply by the height of the image, right? Or add the height of the image. Let's see. Icon image dot height. Wait, so take the height divided by 2. No, I don't need to add that. That'll space it out way too far. I'm just curious, so I want to see what it looks like. Yeah, they're totally off the screen. Okay. As expected. So our Y height is going to be icon Y, which is 0. So cut the resolution of our thing in half, and then you add the offset, and that gives you the Y position. That doesn't make any sense. Why is it only, hmm. So 253. So if the height is 400, or wait, height is 240 divided by 2 gives us 120. Oh, wait, that doesn't make any sense. So if the height is 400, or sorry, is it 400? Is it 800 by 400? 800 by 240. So 120 pixels is where it should be. Oh. Let's run this again. Get the right values from it. Okay, so there we go. 120 plus 5 is 125. There should be a 5 pixel offset right there. What the hell? Oh, wait. So 128 by 128 is 256, which is larger than our 248 or 240 size screen. So it's trimming the bottom half off of the icon. So maybe these aren't 128 by 128 icons. Is resizing them to 120? I don't know. We could just math out the maximum amount of size that we get for icons between the positions that we have. So, like, if we go into, let's go into Krita. Let's open a new one. Let's make it 800 by 240. Let's, image, let's see, let's get some grids. Show grid, tools window, where is it? Tools, under view? Workspace. Here, Dockers, grid, where are you? Grids and guidelines, there we go. Get rid of brush presets. Okay, so let's go ahead and change our X spacing to 128 by 128. So we can see that that's not gonna be right. So do subdivisions by 2, 4, type, rectangle, isometric. Let's do 120 by 120. One, two, three, four, five, six. Man, what a weird fucking resolution. Huh. Alright. So I think if we want to have maximum icon size, see 120 gives us 6 icons, and then we get some room for fudging. Yeah, anything larger than 120, we don't get the easy top and bottom. Because what I'm thinking is with this device, this spacing may only need to be between the top and the bottom row. No, maybe we could do both. So if we do like, let's see, like 72 pixel sized images. Or here, let me take a make a border. Let's do by 5. Let's do a 5-pixel border. Control Shift I, backspace, Control A. One, two, three, four, 5, 6. I wonder if I can move these grids around. Could just do like guidelines. Let's try that. Where are those at? Ruler tool? Oh, that's right. I dragged from the toolbar shown. Is it guides? No, it's not guides. There we go. Show rulers. Then I can drag from here to... Let me just throw these out there for now. Alright, so we got 5 and 5 pixels. Let's move that over there. And then let's do another ruler for the actual icon size. Or not. Here, let's no, I don't want round corners. Duh, I don't want round corners. Okay, whatever. Alright, so we got our 1 pixel by 1 pixel. Let's put this on a new layer. Alright, so then we can move this around. Yeah, 120 by 120 seems a little too big. Like, even if we don't have a border, because 120 by 120 doesn't give us a whole lot of fudge room between these. Yeah, I think this is I don't know, might be a good stopping point. I've been going for 2.5 hours so far. We made some good progress. We got some icons being rendered to the screen, and those are being placed automatically based on our virtual canvas. So Got our virtual canvas being defined here. We set that up based off the resolution of the screen. And then we go through and for our adding icons, we set those up as a path to the icon and then a key number. And then we iterate through, or we basically check to see if that key number is greater than 6. If it is, then we do offsets based off of the second row of icons. And if it's not, then it goes on the first row. And then we paste that onto the canvas, and then we save the canvas. And then over in our code, we've got our canvas being defined and added to the display pad object. And then in our load key mappings function, we go through and we take the icon image from our key mappings, and then we load that onto the device. In our case, we're testing with 12 sample icons, and we're sticking 12 of those onto the device. And that'll go through and call this set panel image. And if we don't pass it an image path, then it goes through and it takes the image from our canvas output. So, cool. All right, well, that I think that about wraps it up. I think we'll pick this up tomorrow or Wednesday. Start working on it some more. We're almost there to the point where we can start customizing the functionality. So we've got like the basics in place for writing images to the screen, receiving the button presses, and doing stuff based off that. So we can fire off keystrokes, we can execute programs, and we can write images to the display. So with a little bit more Python and a little bit more effort, we can have something that's pretty usable. I mean, right now it's usable to the point where I can go through and define this this JSON to do stuff, and then just run this Python in the background, and it'll listen to this device and handle anything that we need to do with it. So that's pretty cool. Does anybody have any questions before we wrap up? Okie dokie. Well, I'd like to thank everyone who tuned in. I hope you learned something today. If anything, I hope you enjoyed hanging out with me while I type some Python and messed around with this device. So if you enjoyed that, I will be doing regular streams of this nature. I don't really have a schedule, but you can check me out on YouTube and Twitch and catch me when I'm live. And otherwise, you can catch the VODs. I upload all the VODs to YouTube, so you can go through and rewatch those at your leisure. But other than that, if you enjoyed this, go ahead, throw me a like and a subscribe. And otherwise, you have a good rest of your day. All right, bye.